Hello everyone. Welcome to this Big Data Analytics webinar live on YouTube. I hope like big data is like very fancy word, and nowadays everyone is looking for the big data and analytics, data science, and like whatnot. But I believe that there are a lot of times people have got issue what exactly big data is, what exactly data science is. Are these things are related? Are these not related? In which area big data will be used and whatnot, right? So this particular webinar, yes, we'll be talking about this. So here we'll be having introduction to big data and analytics. My name is Nilesh Gule, and I'm technical director at SunBeam Infotech. More than 16 years, I'm into the training, teaching onto the application development, as well as into the big data technologies, into the embedded technologies, and so on. Last few years, I'm into the big data, probably delivering big Hadoop, delivering Spark, Hive, and probably other courses at Sunbeam. Definitely, this um, live should be helpful for mainly the students or freshers or even professionals who want to know what big data is, and then how this big data probably should be gone through, how we should take a look at this, getting an overview where this will be like applicable, what kind of opportunities that we will get to know into this particular big data world, and then what is its relation with the term called as a data science. Correct? So here we go, and we want to talk about first and foremost what exactly big data is, and more than that, from where this big data come from. So the very first thing we want to talk about is this big data. As we discuss, this big data is all because of us, I would say, because things are changing rapidly over the period. Long back, probably people were not having internet and like many other things, but definitely now you found that internet is becoming inevitable part of our life, and with internet being inevitable part of our life, a lot of data is getting generated over the every day. Nowadays people are like having almost like 1.5 GB data, at least in India, available per day consumption, and then people are successfully able to consume that as well. So where exactly we are consuming all this particular data? Correct? Yes, let us take a look at that. So I'm very sure the lot of us, we are on like social media, Facebook, Twitter, LinkedIn or whatnot, and then lot of sending the post and probably liking images or whatever you talk about. So yes, lot of data is getting generated out of this. Going ahead, lot of transactions we do nowadays online. So your banking and your finance data is also contributing to the big data. Your old history, what we talk about, a lot of history is available into the mainframe, mainly the BPO sectors, and even some of the banking sectors. Yes, they are having our all historical data. Correct? So it is there. Nowadays people are preferring shopping on Amazon and like other online players, right? So again, we are producing a lot of data over there. Correct? Apart from this, probably people, your traditional cable TVs are getting outdated, and people are moving towards web series, and then internet based platforms like Netflix, like Hulu, and like whatnot. And then we, apart from this, if at all you get a free time, I'm very sure people are playing a lot of games. You must have noted that a lot of times you play game, the games are even giving you a lot of offers that for doing this or for activating this you should connect to the internet and that kind of stuff. You must have noted that. So if you at all find that what exactly they are trying to do, so many of the gaming platforms, you must have seen that what they are doing, they are trying to capture your moves. They are trying to find that how you are defeating the computer, and then by recording your moves they are trying to upgrade their game in like every subsequent releases, right? So the things, all every nonsense thing that we might find that we are doing on the internet is actually getting recorded on some servers, and people are using it. Now it is all about, you need to understand that how people can use this particular data, correct? Then you need to understand that from this big data came from, actually, you find that a long back, nearby 1970s, first time rdbms come into picture. As rdbms was there, people were doing lot of development, and that development was more or less at the local level. So people were having their businesses in a local market, and that's why amount of data that was getting generated was not that much. But over the period, we found that the internet and www comes into picture. With www, people started sharing lot of static data, correct? And then as the static web pages are like becoming available for the information, people finding that, oh, we are able to share the information so easily. But so far it was all about static pages. People were not able to really do a kind of a business on internet. If you are really looking for doing business onto the internet, then people were still waiting for, because the pages were merely html pages. So first time somewhere I would say that Java come with like applet, and then that makes somewhere popular. People get the idea that we can have an interaction with client, and then client can communicate back, send data to the server and receive data from the server, can be data can be stored on the server side, and people realize that yes, your business can now go on a next level, correct? And this is where, in my opinion, we begin with the burst of data. And then something rdbms that is started by 1917, probably generating, let's say, kbs of data, or let's say mbs of data, or like gbs of data. Now your data start exceeding probably hundreds of gbs. As your data started exceeding hundreds of gbs, please note, as your data started exceeding hundreds of gbs, somewhere rdbms start finding their limitations. Your sql queries getting really slow when they are working on that, correct? So people then started thinking of, okay, what can be done better, correct? So people were started thinking of how this data can be managed. And in order to manage this particular data, people were saying that we want to go beyond sql. And this is where NoSQL, or not only sql, came into picture. Probably 1998 was just a starting, but next 3-4 years there are a lot of work done on a NoSQL databases, where they prioritize huge amount of data than a typical consistent data, correct? So far your data was more or less generated by the human beings, probably for the financial reason or for other reasons. But real boom to the big data, in my opinion, is that where the machine started producing data. Again, at the early times you find that the iot, yes, iot is quite old, but the iot in action, if you really see that, the lot of, from year 2008 and onwards, lot of people, they realize the potential of the machines and even mobile phones, correct? So lot of small devices, they were started generating a data. So devices might be set up into the plants, or probably other places, probably smartwatches and all that. Yes, people started talking about in recent years. So they are trying to produce some data consistently, in a periodic basis, and all this data is getting recorded, correct? As this data is getting recorded on a server, you really want your data to be processed there, isn't it? Apart from this, you go ahead, there's somewhere your phones are quite old, but your smartphone era probably somewhere becoming common by year 2011 and onwards. And people found that they can use internet so heavily nowadays. And this is really, you find that a huge amount of data is getting generated. And then a lot of companies really start seeing that you are able to capture this particular data, you can get to know a lot of information about your users. And as you are able to get a lot of information about your users, yes, you can probably influence people, you can do your business at the better way and whatnot. And but question was that how whatever this particular data is getting generated, how this data will be handled, how this data will be managed. And yes, this is where we start talking about big data technologies. And then like big data technologies like came up where you start talking about, initially people were talking about like a NoSQL kind of databases, but over the period somewhere like Google, taken initiative by year near 2000 or something. They started working on like Google distributed file systems, or let's say Google big table, where Google tried to capture huge amount of data mainly for their search engine. But over the period, since it's like a very much proprietary, other players were also trying hard. And over the period, people also started coming with like a Hadoop kind of stuff. Like Hadoop first release was available by 2006 2007. But again, there was an issue that people are started using a Hadoop. It was like quite good, was able to handle huge amount of data by that time. But the issue was that your whole coding was like oriented towards Java, and it was like bit difficult. So somewhere the Facebook trying hard to manage, or let's say process their data, but dealing with Java was something making it like more complicated. Over the period, probably Facebook people, they go ahead and start developing a kind of a tool. They call it as a Hive. What it actually does is that you need not to know really Java. What all you need to know is that a kind of a SQL queries which were really popular and people were already expert into. And this kind of Hive kind of tool, start converting your SQL queries into the Java programs, what you call them as like a MapReduce programs, onto the Hadoop, correct? But again, people still find that things can be done in a better way. So over the period, the big data is like very much evolving field. Over the period, the technologies like Spark come into picture, correct? Which brings a lot of simplified programming model. But let me tell you guys, all these technologies are dependent on each other. And these are like just few that I have pointed it over here. But there are many more technologies, many more frameworks, distributed frameworks are there into the market. And these distributed frameworks, learning them, using them is all people started talking about. This is to be done into the big data, correct? I'm just going ahead, but we need to take a look at what all, how much data is getting produced on internet. This is just a quick look at this, like a giving example by year 2020. This is a summary that 1 minute of internet, how much data is getting generated. I said that within 1 minute, how much data is getting generated onto the internet. And then you can see some of the like very interesting facts. One thing you might have seen that Google itself, you can check that Google itself is having 4.1 million searches per minute all over the world. And I'm very sure more than 70-80% of these must be coming through software developers working into the different technologies, isn't it? Then a lot of people, they are active onto the Facebook. So Facebook, like 1.3 million people are logging in per minute. You find that text messages sent on like a different messaging, you find that it's like a 19 million messages are getting sent per minute. You should be able to see that 4.7 million videos people are viewing. So you find that so many people are there on the internet all over the world per minute. As we say that nowadays it is like an era of smartphones. In an era of smartphone, you should have seen that having Android and iPhone apps. So you find that these apps are like very common. So you'll find that around 4 lakh apps people are downloading per minute. And then nowadays even Instagram is like becoming popular. So many scrolling Instagrams are there. The Twitter, the lot of people are like doing tweets, obviously include a lot of like industrial influencers, like political people, and many others are there, definitely. So many tweets you are able to see. Surprisingly, even when Tinder swipes, you have like 1.6 million swipes per minute. I hope this is like very interesting one. Going ahead, yes, people also do work, people also do send emails. And you find that a huge amount of emails are getting sent over the period per minute. People are not only keeping themselves to YouTube, there are other platforms are also available like Twitch and YouTube. and 1.2 million live streams people are viewing all the time. Twitch is very popular platform for the same. And this like another interesting one, TikTok. I'm very sure this will definitely affect with like India banning TikTok, but definitely the other places you'll find that still 1400 downloads per minute was quite huge. Another interesting thing, as I was talking about IoT, you find that probably I was checking last year. For the last year, hardly 7 Amazon Echo or like smart devices were getting shipped. But probably this year, this thing has been changed from 7 to 305. So like Amazon Echo, Amazon Alexa is like getting popular day by day. Google Homes, like people are getting this kind of new ways of their living. Correct. Apart from this, the like a network for your images, your image hosting sites, popular image hosting site, like 2.5 million images are like per minute people are viewing. I'm very sure even though text messages are less, definitely WhatsApp and then other hike and other ones, they are getting popular day by day. Correct. So apart from that, you'll find that, please note that people are also spending a lot on internet. So you find that somewhere like 1.1 million dollars people are trying to spend per minute. I hope this is again a surprising number to think of. But then even as I was saying that nowadays web series and everything like getting popular. Netflix is like only one like most popular, but like Apple TV is there into the market, Amazon Prime is there, and like many other are there. Correct. And you found that the like even 7,64,000 hours are getting watched. Again, so many people around the world are using these kind of online platforms so heavily. And obviously every time, everything that you are doing on the internet, you know producing a huge amount of data. And this huge amount of data, who is going to process that data? Correct. And this is where your big data started picking into the picture. And then we want to talk about what kind of data that we have got. Please note that by the time you were working on RDBMS, people were saying that all data was managed under rows and columns only. Correct. All data was getting managed under rows and columns only. Correct. The data was highly structured data. Correct. Your data types were like well-known data types. We were saying that dealing with numbers, dealing with strings, and all that kind of stuff. So you find that so much of data was available onto the what is that structured format. You find that around 20% of enterprise data, one of the Gartner report says that that much data is in a structured format. But please note that it is only 20%. Please note. Correct. Because traditionally, even though we started with the financial data and all that kind of stuff, because of this social media and like other platforms, you find that apart from this, the lot of other data people are started talking about. And most of the data that we are starting now, this nowadays data, it cannot be really explained in terms of rows and columns. It is not possible. This particular data, you'll find that it is like mostly in like a audio video format. Correct. Or probably your like word processing files are there, or your data is like emails or like your Excel sheets or not. Then you realize that, please note, around 80% of data nowadays, it is in unstructured format. I hope you are able to see that. And this is giving you the opportunity that you need to go beyond this, because the structured data, usually people were talking about RDBMS. And unstructured data, now people are looking at what we can do with this. Please note again a very common misconception usually people have, that images are not structured, or your audios are not structured, or your videos are not structured. I guess we should spend a minute understanding what is structured and what is not structured. If you are aware of, images definitely have got some file format. A file format like JPG, a file format like GIF or PNG. These are well-defined file formats. Your audio, let's say MP3, or your audio, like what you talk about, what is that, WAV file format. These are like well-defined file format. Then people ask the question, if it is so much well-defined file format, then why we are saying that it is unstructured data. Please note that your file formats are known, but what you have stored inside that, that is not known. Probably I can give you image, you can have a program to read an image, but it is not very easy that by looking or like a programmatically understanding whether that particular image is of some nature photograph or some human photograph or like something else. Now that is not something that you can define it very easily. I may give you mp3 file, you may write a program to read, load that mp3 file, but writing a program which is able to find out whether that mp3 file is a song or that mp3 file is a speech or that mp3 file is like something else, I believe it is more complicated stuff. And that's why I always say that when I say it is unstructured data, I'm not talking about a file format, I'm talking about the contents. You cannot really start predicting the contents of it. And that is the reason I'm saying that these data are like more or less, I'm saying this data, people call it as unstructured data. Obviously, handling such unstructured data is much more complicated as compared to your RDBMS SQL queries, correct? But wait, apart from structured data and unstructured data, there is one more category. People start saying that it is semi-structured data. What is semi-structured data is all about? As a semi-structured data, it is a structured data, more or less like a structured data, but this is more flexible. I'll just try to give you example. If you have seen a Facebook post, long back, earlier, I do recall that the long back Facebook post, we were able to put only the text and kind of an image and only the like. But over the period, Facebook post has got a lot of new feature. You can tag other people, you can put your location, you can put your emotions, you can put your probably many other, you can give a reactions and so on and so forth. Please note that your structure of post is getting changed over the period, right? Then apart from this, the semi-structured data, as we say that unstructured really need much more storage, correct? But then within lesser storage, you want to keep some good amount of data. I guess semi-structure is definitely better in that case. Do take care of it. Please note that most of the time you'll find that a semi-structured data is hierarchical structure, correct? Or it is kind of a key value pair. I'm very sure some common file format that people are usually talking about when it comes to semi-structured data is either XML format, or let's say is a JSON format. Even sometimes even CSV formats we can talk about. These kind of formats are not very well defined, but still they have got their own organization. I talk about, we have got data like a structured data, we have got data, let's say unstructured data or like a semi-structured data. Now, but every problem you start saying that cannot be a like big data problem. A lot of time your customer comes down to you and then start asking you, okay, I have got so and so and so kind of problem. So does it really mean that that particular problem we are going to consider that particular problem as a big data problem? Is it like that every problem given by your customer, end customer, you want to handle it using big data? Oh, not really. So how do I define how these architect people take a decision which problem to be done in a big data technologies? Please note, a lot of people have got consideration that big data is something going to replace your RDBMS. No, it is not. RDBMS has got its own strengths. It can manage your structured data very well. It can give you the strong consistencies, what you call it as acid transactions and all that. However, you cannot really get that when it comes down to the big data world. So they are not replacement, guys. You first understand. So how do I decide which problem I should be considering as a big data problem and which problem I should be considered as like a normal problem? Correct. So usually when a problem comes, they are usually thought on like a 3-4 parameters. There are many such parameters are there, but at least 4-5 parameters can be discussed. The very first parameter should be discussed is around volume of a data. Then if you are really dealing with the data into the MBs or probably few GBs, I believe that you should not really worry about big data and kind of stuff. But moment you say that my data is started getting in a hundreds of GBs or TBs, or for that sake nowadays people are going to data in a petabytes and hexabytes of data. It is people say that nearby by 2020 we will be having overall world data, the data universe will be of more than 44 zettabytes. Correct? So the way data is growing, day by day, you can expect such huge amount of data will be available on the internet. Then the question is you want to just talk about, so just having a huge amount of data, do you want to say that your problem is going to be a big data problem? Oh, not really. Just by that you cannot say that your problem is big data problem. You need to also take a look at, say that for example I have got 2 terabytes of data, but that data is stationary. Correct? It is a fixed data. So I really do not say that you should count it in a big data scale. You need to also worry about the rate at which data is getting generated. And definitely we talk about velocity. Just some time back I was trying to tell you what is happening in 1 internet minute. The what amount of data is getting generated per minute. If that kind of data is getting generated by you, I believe now you should really worry about it, because having 2 terabytes of stationary data, and then moving data where you are trying to get a data in gbs per minute, I guess you need to worry a lot. Correct? These kind of problems usually you start talking in terms of, let's say, velocity. Going one more step ahead, I'm also talking about the variety of a data. Oh, what is variety of a data? I'm saying that it is not like that your data should be fixed data. Correct? Your data is like varying data. Just now we were talking about the structured data, unstructured data, or let's say semi-structured data. So when you got a variety of a data, yes, your big data makes sense. Initially, as people started with the big data, people were talking about only these three things. One is like volume, velocity, and variety. But then over the period, people realize that just having huge volume of data, or like huge velocity of data, or huge variety of data doesn't make what is that problem eligible for big data processing. Means what? Suppose that some of your customer come down to you, and your customer says that I have got some 10 terabytes of data, a data of like a different formats, like I have got pdfs, I have got, let's say, audio files, and etc etc. But he say that even though I have got a huge amount of data, even though I have got data of like a different file formats, I'm not very sure that whether this data is correct, or how many wrong values are into the data, or probably I'm not very sure whether the data was collected correctly. I guess if the person, your customer itself, is not very sure about his own data, I guess how you are going to talk, how you are going to process that particular data. So this uncertainty of data, the trustworthiness of data, you talk about veracity. Please note that it is very common that at least 10-15% of data, your data is missing, or your data is like wrong values that are always acceptable. 10% of data you can always apply some of the formulas and able to handle that. But what if your 50% or like more than that data is not sure, or having this kind of stuff? Now I guess unfortunately you cannot rely on that particular data, and like processing such data is like very difficult. Let me tell you guys, the biggest challenge in a big data world that probably we are facing nowadays, or like a machine learning world that we are facing right now, is that you have a lot of data, but making that particular data usable, cleaning that particular data. I have seen that many of the big data projects that we people are dealing with, you find that more than 60% of project time is literally invested in cleaning a data and making data usable. Correct? And that itself is a really big challenge, just to make data usable itself, or first before that even understanding that particular data. Correct? So these are like a big data characteristics that you want to apply. I guess that I should not keep on telling you only the general stuff. I believe you can think of, and you can put some kind of thought process as well, just to give you idea how your big data is going to be different as compared to your normal rdbms. Some of my friend is having a kind of ngo, and what he's doing, they are trying to organize kind of blood donation camp. They thought of that they want to collect some information from the donors. Why they want to collect the information from the donor? Because next time they are trying to organize that particular blood donation camp, they should be able to contact their donors back, and they try to make each blood donation camp a huge success. The question is that we can definitely think in our regular rdbms point of view, And our regular RDBMS, what it teaches, what kind of data we should really think of, what kind of data we should really try to, put in, right? So I'm very sure you must be thinking that I should be started taking a blood group of that blood donor, correct? I should be probably taking, the name of that particular uh, donor. I want to probably get in the medical history of the blood donor, whether he has got kind of diseases or anything like that. Yes, I want to take a look at that as well. Apart from that, probably I want to know what is his last blood donation date, isn't it? Correct. You do not really want to call a donor who has donated a blood just, last week. Correct. You might be interested, taking his gender and other information. And definitely you're also looking for some information through which you can contact it. But this is what RDBMS tell us, that what all information you find it relevant, please take up that information, the information using which you can put these details into your server and try to use it in future. But your big data try to tell you that you need to start thinking bit differently. Big data says that your every data is important. It is not like only name or blood group or something like that. Please start thinking of it. In this particular scenario, do you really feel that you should take a salary of a person? Do you really feel that you want to take an occupation of a person? Or probably do you really feel that you should be taking religion or like a caste of a person? Do you really believe that this kind of information really makes sense when it come down to the blood, what is that, blood donation camp? I'm very sure you say that this information is really nonsense, because you really do not want to take such kind of information from a donor. This is what your ethics says. I know this is what your ethics says, but big data says that please think differently. Please note, your RDBMS is always teaching you, what all things that you should collect. But at the same time, your RDBMS is teaching, kind of normalization technique that we talk about. It also tells you that which data you should not worry about. But your big data start, thinking starts saying that please collect every possible data, whether you find it ethical, whether you are not finding ethical, sooner or later you might be able to use the data. Just to give you information, probably if you are at all getting kind of a, let's say, salary, obviously the salary is not really important, but by that you get to know that whether it is a rich person, whether it's like a middle class, whether like a poor class, or what exactly. And depending on, probably as you get to know that more and more rich people are like donating a blood, at that time you might think of putting your next blood donation camp into the rich area of city. Probably if you're in Pune, you might be willing that you want to go to like Koregaon Park or some kind of area where there are chances that you will get a lot of like rich, donors who can donate your blood. Or probably you realize that the salary is probably very less. You want to go for like kind of slum area. Please note that that will make your blood donation camp a huge success. Again, probably let's say for example, if your information, whatever data that you have collected for last 10 20 camps, if you get to know that lot of software developers, they are donating a blood. If they are donating a blood, I'm very sure, why don't you plan your next blood donation camp into Hinjawadi IT Park or like Kharadi IT Park? Don't you think it will be a huge success? So your occupation may not be useful for the donated blood, but this kind of information will definitely help you to take a decision where you can plan your next blood donation camp. And something similar, you must have seen that in any city you will be able to find out that certain areas are occupied by certain religious people, correct? So if some XYZ religion is like donating blood quite good way, so why not you think of arranging the blood donation camp into their area, correct? I'm just saying that how you start thinking differently when it come down to the big data world. So it is important that you begin your thought process first. And as you understood thought process, I just take up like kind of some example where I want to talk about where this particular big data is like useful. Nowadays, both of these words are really going hot. Like somewhere people are talking about the IoT and people are talking about big data. I personally believe that things are really going hand in hand. so many projects that probably I have seen so far. Many of the project nowadays, they are driven due to some of the IoT sensors. Now that projects could be like your Ola and Uber kind of projects, which are taking a data from a GPS, or probably there are projects which are taking a data from like a smart meters or something like that, or there are probably the whatever the lot of health data that is coming up with the smart watches and mobile phones. It is there. So your mobile phones are able to capture the huge amount of data, and then people are trying to use it in like lot of other industries, including the insurance and so on others. Correct. This is just I'm trying to give you like kind of ideas where the things, data can be used. Let us take a one very small simple example. Let us say that I have got kind of a home automation system, and in a home automation system, that I have got like plenty of different home appliances with me. Now whatever home appliances like lightning system is there, or probably your TV is there, or your D2H system is there, or your speakers are there, or for that sake your gate door information is there, or probably your air conditions are there, your media servers are there, your oven is there, probably you might what is that, refrigerator is there, and whatnot. The lot of we have got electrical appliances. Just visualize, I'm saying that a very small information I'm trying to collect, a very small information I'm trying to collect is that whether it is on or off, and probably I'm trying to take it after every 15 minutes, only 15 minutes. But I want to say that whether the it is on or off, you can definitely go ahead and make it more complicated, understanding what is AC temperature, or like understanding what is like how you are using oven and etc etc. But for sake of simplicity, let us just consider that after 15 minutes, every 15 minutes, I want to know how much, which all appliances are on, which all appliances are off. I'm collecting a data and sending on my server after every 15 minutes. The question is that, do you really believe that this kind of problem can be a big data problem? Do you really believe that this particular problem can be a big data problem? Ideally, you always say that, see what all appliances that we have got. So like one home, you can have like hardly, 15 to 20 appliances. With 15 to 20 appliances, you are just keeping a value true and false. I believe that it is really a small data. And even though you are generating, the data after every 15 minutes, I'm very sure that, if you just keep generating for a home, even, you spend few years, you'll not be able to reach even MBs of data. Correct. The question is that, is it a big volume? Is it a big variety? Is it a big velocity? Doesn't look like. But why don't you think on a bigger scale? What if this home automation project you have fit in every home in a smart city? I guess India probably we were having a projects of like smart city. Just consider that your decision has been taken that we want this particular home automation system is to be set up into every house of a smart city. Now you just start visualizing it. Now so many different houses that you have got. With that, don't you think that there's the huge you know velocity data is getting generated from so many different houses is the first. The second, huge volume of data. As you have got billions of homes, definitely the volume becomes too big. And what about variety? Please note that I'm very sure you people understand that appliances, number of appliances in my house will always differ with the number of appliances in your neighbor's house. And now you never know that which house will have which all appliances. Correct. And then you find that it is a variety of data, huge volume of data, huge velocity of data. And with all this, I'm very sure you will be getting a lot of amount of data. But where I can utilize this particular data? Now as you are getting a data, please start thinking of it. You can always analyze a data of 6 months, and you will automatically understand at what time or in which days the maximum usage is there, or in which time we have got like a minimum usage of a data, isn't it? Now with that maximum minimum usage, you can always guess few things. Like if you track one particular house and you realize that this particular house on weekdays 9 a.m. to 5 p.m. there is a minimum electricity usage. I hope you can always think what you can think of. You will realize that there might be these people going to the offices. Correct. So you are able to understand how your users are behaving even in their day-to-day life, just having enough of data. Think of it. You just go ahead. You can, if you understand the pattern of using the appliances, I'm very sure you can definitely give this kind of information to those people, who those industries who are making such kind of appliances. So they will be utilizing your data and deciding how they should make their appliances, which will have minimum electricity. Correct? Apart from this, if you really understood that this particular data is like the way electricity is getting used, you can always start thinking of, and you can start giving even inputs to the government that probably last 2-3 years of data, this much electricity is getting consumed. You can start predicting that there are quite good chances that next few years, 1 or 2 years, there will be like more than requirement, and at that time we should start thinking of some like electricity plants or something like that. So new products can be set up, new plants can be set up, new ideas can be come up. So having a data with you will help you to take better and better decisions. You can just take, like right now into like we are into the COVID situations. With the COVID situations, you must have seen that people are talking about, they're like a, at the way, the rate at which the COVID is growing, you find that. So there is a lot of scope. If you really start capturing a information, probably we have got like a Arogya Setu app, so it is capturing the information. Probably Google and like Apple, they are working together to track this particular COVID spread. Now just think of it, if you just start getting these kind of apps and start collecting that particular information from so many people using that, don't you think it will be again a huge possibility? Correct. Nowadays, I'm right now probably a few months back me, and last month itself I was trying to work on some project where I was trying to find out data regarding that COVID cases even in India. And trust me, it is very difficult job, because the data that is getting collected, it is not so straightforward. The lot of data that is getting published from a government is probably in terms of PDF files or something like that, and again cleansing that data itself is very difficult. Even getting a data at the government end itself is troublesome. Just think of it, if all our testing devices are like enabled with internet, and moment you found like positive cases, if that is getting updated onto the server, I guess this testing services, it would have become much more simple, isn't it? Apart from this, you have got your treatment. So people are still struggling with the treatment. People are trying to find out how probably patients are responding to the treatment. So somewhere, if that kind of information is collected, that information can be studied over a month or something like that, and you can try to understand what is the best possible way to treat the COVID patients, isn't it? Right now I guess a lot of vaccines are there, and they're into the trial basis. Now when vaccines are into the trial basis, let me tell you that when they are tried, the lot of sensors are like connected, and they're your patients, they're like examines, and with that examination you want like a huge amount of data that is getting generated. You need to process it in a very short amount of time. Correct? And if that data is going like say very short amount of time, don't you think that now how you are going to process it? You really do not want that the data is to be collected and to be processed after a month. We are already running short of time. So I'm saying that these are the areas where big data is making sense. I just given you a couple of example like home automation system where IoT, or like in this kind of scenario also people are doing that. Trust me that Google and Apple, they are working on even a backend data structure where they are trying to manage the huge amount of data that is started getting from the cell phones of the people. Correct? So I'm just talking about that. Apart from this, this like a hot topic every day and people are talking about, and people are like very much worried about, sir, what that big data is all about, so forth. Correct? So I believe that it is worth, I should be talking about what kind of opportunities that we have got in the big data world. Right? And then I'm saying that we want to talk about, let us just, I'll just give you a bit idea how the things are. I said that by year 2018, I'm saying that few years back, the big data and analytics market was 169 billion dollar. Please note, purposefully I'm putting kind of bit of history, saying that by 2000 itself, 2018 itself, it was 169 billion dollar industry it was. However, now you found that it is predicted that by year 2022 this will grow to nearby to $74 billion industry, because people are like day by day increasing the usage of internet. And trust me, this pandemic was not really counted in. If you really find that in this pandemic, lot of people are now connected onto the internet, and the people who were not even using internet earlier now started using internet heavily. I'm very sure this has increased your data tremendously, correct? So going ahead, there are a lot of different words, when they come across the big data, when they come across data science, and people are just these kind of words, people are getting very much confused. I believe that we will be just let's list down some of the word. People talk about data warehousing, people talk about, let's say, data analysis, and then people are also having a word, what is data analytics. Somewhere people talking about like a data mining, or somewhere people talking about like a business intelligence. Somewhere few people are talking about, let's say, machine learning. People are talking about deep learning. People talking about, let's say, artificial intelligence. People are also talking about, let's say, where cloud computing or parallel computing come into picture. So don't you think that the people are coming up with so many different words, and then people always have got question, yeah, all these kind of words are there, what exactly big data is, what exactly data science is, what exactly, if I at all planning that I want to learn something, what exactly I should learn, if I want to apply for a job somewhere, what exactly I should apply for a job. I'm very sure these kind of questions everyone must have. So I'll spend some time in telling you a quick understanding the difference between these kind of words. So we'll try to talk about some words where people are like likely to make some kind of confusion, and then you also understand what you want to learn, or what where you want to apply for the jobs. Please do take care of it. So there are like couple of words I just collected over here where we can compare them. Just to start with, have a look at this. We have got a word called data analysis, and at the same time we also have a word data analytics. What exactly differs? Let me tell you, make it very simple. Whatever data that you have, whatever past data that you have collected, based on data that you have collected, you want to do, you want to understand in your data, you want to get to know what, let's say for example, you have got a data of sales of last 2 years. Now you want to know that which quarter you make the highest sale, or which product sale was like maximum, correct? Who is like your most valuable customer. Now this kind of analysis of your data, I would say, is the data analysis. But then what is data analytics? Now, analytics and analysis terms look similar, but let me tell you that your analysis is always talking about the past and your present, past and present data. Analytics is something where you start talking about the future. Let's say that you have got sale of last 2 years, but now based on last 2 years sale, you want to predict what should be your sale for the next year, or what should be your sale for the next quarter. Now moment you start talking about in terms of prediction, yes, you started talking about future, I say that it is like analytics, correct? You want to know probably like XYZ product right now going on your company, and that product has done some business in last 3 years. You want to know that will this particular product will continue to make a good business into like upcoming years, correct? Next year or next quarter, how you can take up decision onto this, correct? This one, I say that it is the analytics. Please do take care of it. Going ahead, we want to also talk about then, sir, what is business analysis or business analytics is. Please do understand that when you talk about business analysis, when you talk about business analytics, it is again, I would say that it is data analysis and data analytics only. However, when you say business analysis, you're talking about data of your business. When you say business analytics, you're talking about deciding the future of your business. Please do take care of it. When you say data analysis, it can be even a random data. When you say that data analysis, it can be general of your data, digital signal processing kind of data. That data you may talk about, or you may have got like a general census data and all that kind of stuff. You might be interested talking about that. I say it's a data analysis. But moment you start talking about sales, moment you start talking about customers and all that kind of stuff, I would say that over here I will discuss that this particular data is related to the business. So forecasting related to the business, you start talking about business analytics, correct? Going even one more step ahead. Apart from this, there is also word called data visualization. Please note, what do you mean by analysis and what do you mean by visualization? When you talk about analysis, you are just analyzing what is maximum, what is minimum, what is highest, what is lowest, what is average, or probably you try to generate the reports in like a tabular format or something like that. But trust me, understanding this is possible at the lower level. How you are going to report all this information to your seniors, how you are going to report it to your CEOs and your directors, how they are going to take a decision. Are they really going to read all your customer information and all your sales information, and even though you have done summarization, reading those all tables are like very difficult. So don't you think that you want all this kind of stuff to be put in, you want to put it like all this kind of information onto the more readable format, probably more on a kind of a diagrammatic format, you try to put it like a graphical format, correct? You say it's a data visualization. So you have like bar chart, or let's say line graphs, or whatever that you want, correct, pie chart, and etc., where you try to explain your seniors in a very quick and better way, isn't it? Going even one more step ahead, if we also have got one word, data analysis, and we have got like a data mining. How the data mining is differing in analysis. Analysis is, just now I told you, is more of like analyzing what you have. But when you say data mining, goes one more level ahead and start looking at, are there any patterns? Like you start talking about, you have got like some XYZ customer, and that XYZ customer, how exactly he's purchasing your products. Like he's purchasing probably every quarter, or probably he's purchasing first quarter of like every year, or what exactly. So you are trying to find out the pattern from your data. Yes, it is like more specialization of your analysis, I would say. You start talking that it is data mining. But there are like even bigger words that come into picture. People have got question, so what is artificial intelligence? Or people have got question, what is, let's say, machine learning? Or people have got questions, what like a deep learning? What these all words are? And are there all confusions? Please note that artificial intelligence, we always say that it is a very bigger term. It is much more bigger term, and that term usually talk about your mathematical skill set, correct? And lot of your data structures and algorithm skill set, please do take care of it. All this kind of stuff you need in artificial intelligence, correct? But over here there are more than rules that you are defining. So if you have ever worked on data structure, you say that a star search algorithm and kind of algorithms, they are very heavily used in artificial intelligence. Like you said driverless cars and all that. Yes, people are using that. Or you have got, let's say, robots, how the robots are going to move, and etc. Yes, people are using AI over there. But under the AI, there is like one more term, that instead of you putting a mathematical rules, why not you go one more step ahead, and based on your existing data, you tell your system, why don't you define your rules on your own? You see some past data, you understand that, and based on the data available, you start, you learn yourself and take your own decisions. And this one, I would say, it is a kind of a subset in AI. I call it as a machine learning. Please note that your machine learning is more of statistical base. It is like more of statistical base than mathematical. Yes, mathematical is definitely there, but I'm saying that it is more of depend on a stats. And then apart from that, it is not only about the past data, but you want that these are still machines. You do not want to learn them like a machine. You know that human brain is very fast in like learning anything new, isn't it? And if your human brain is really fast in learning something new, why not use a technique like human brain? And technique like human brain, I'm saying that it is like a deep learning. Let's say deep learning. The deep learning follows similar structure as of human brain, what we start calling as the neural networks. So I would say that deep learning would be even deep learning would be even subset of machine learning, which mainly talks about neural network kind of stuff. And then I would say that it is nowadays getting popular day by day, correct? A lot of frameworks, they are using that. But this is like a relation where you can say that AI, a subset you can consider like a machine learning, and its subset you can start considering like a deep learning. Do understand that? And then one big question that everyone is having, that people are talking about every day, we have, let's say, data engineering or it's a data science, and people are very much confused. So what is data engineering, what is data science? So far I was talking about all big data. As I was talking about big data, handling that huge amount of data, somewhere you say it is a data engineering. So you managing your infrastructure, having the frameworks which are able to deal at that higher end and able to handle such a huge amount of data, processing that data in a fastest possible time, you start saying it's data engineering. But then what is data science? Please note that data science is a bit different. Data science, you start saying that even though you have got a huge amount of data, that what exactly processing is to be done on that huge amount of data. You cannot really think of having some terabytes of data and you process that terabytes of data to understand whether certain algorithm will work or not. I guess that is nonsense. So based on that, what people do when you talk about data science, instead of dealing with the terabytes of data, you take some sample of that particular data, and on that particular sample, a small sample of, let's say, megabytes is sufficient. You try to see the pattern in that particular one. You try to decide what algorithm I should be choosing, what operations I should be doing, correct? And once you understood that, yes, even that megabytes of data, you are able to do the processing. In future, you might say that the same processing, I will try to do it into the data engineering, correct? So now these are certain ideas I was just trying to talk about, correct? Data science and data engineering. One quick real life example probably you can talk about. Let's say for a birthday party, you get a cake of, let's say, 5 kg. You got a cake of, let's say, 5 kg. Now to understand that cake has got which kind of ingredient, is it really required that you want to eat all those 5 kg of cake? No, it is not really required. You just take one piece out. As you take only one piece out, you test it and you understand that, oh, this particular cake is having so and so and so kind of ingredients, isn't it? I'm saying that, dealing with that huge amount of cake, probably you want that 5 kg of cake I cannot eat alone. Probably I will distribute it among, the family members, among my friends. And that's why I say it's a data engineering. But before I started distributing it, just to get idea whether the cake is good or not, what ingredients are there, I take a small sample and I try to find out that. I say that it is a data science, correct? Please note, things are interrelated. I'll just tell you like one or two projects where you understand the difference between data science and data engineering. Probably a projects that we can discuss on. You must have seen that we have got, let's say, Airtel, we have got, let's say, Idea, and we have got, like, many others, telecom player in the market. Let's say that there are a lot of people using this particular telecom domain. They have got your phone calls, they are using data, they are sending SMS, they are doing phone calls. Now they want to calculate the monthly bill. If you want to calculate monthly bill, so all these records, call data records, they call it as CDRs, they are collected. And now, at the end of the month, you want to fire, some sort of a job which will calculate this. Obviously the data is so huge that you do not want to process it in a normal RDBMS. It may take probably, literally 10 or 20 or 30 hours for processing it. So people started thinking of, let us use a big data. And I know that there are a lot of telecom, even in Maharashtra, they are generating their bills by using a data engineering. So they are using probably earlier Hadoop, Hive, nowadays probably Spark. People are using that and trying to, process their bills, correct? So this is purely data engineering. But wait for a minute. Apart from this, let's say you must have seen that nowadays these Airtel or like Idea or like other vendors, they are trying to suggest you kind of best plan depending on your usage. Now whatever your usage is, now studying that particular usage and telling you what is most, suitable plan for you, I would say that this is more or less related to a data science kind of activity. So you can always take a like small sample and try to understand, and where you find that, you can try to understand that, okay, what kind of usage this person is doing, and then you will find out what is the most suitable for him. So I say that such kind of classification problems that can go into data science level, but like your billing calculation of huge amount of data, that can go in a pure data engineering. And there are times, things get merged together. let's say that your XYZ algorithm, you tried on 1 MB of data and you realize that this is quite good algorithm. Now you want same algorithm to run on probably a terabyte of data. Now, even though algorithm is of machine learning algorithm, since you want to operate on terabytes of data, your regular Python may not be sufficient, correct? So at that time, you might be thinking of putting that algorithm at the bigger scale, correct? Now people have a question, oh, these are all things are there, so which all different tools that we can have to deal with this? Now please note that when it comes down to the big data, you have got, data storage, correct? You need to think of lot of storage tools, like you got Amazon S3, or you will say HDFS we are trying to use, or data warehouses where you are trying to store the data. Apart from this, you have got whatever data that you have got, you want to visualize that data, you want to generate those kind of reports. So we have got a lot of business intelligence or like a data analysis tools, they are available, correct, into the big data world. Apart from this, you start saying that you want to take a sample and you want to process on that particular data, or let's say you want to apply some AI algorithms on the top of it. Yes, again, you'll find that you need now base of kind of mathematics or statistics or your computer algorithms that you want to learn, might be correct. And then programming languages which probably are more popular into this are R and Python. You must be aware of that. Apart from this, once it is ready, it's like a data science part. But if the data is like too huge, I guess you want to process it at the bigger scale. So definitely few people might be having question, oh, what is Hadoop, or what is this Kafka, what is Spark, or like languages that you can use like Python and Java for this kind of programming. Now these are, let it be Hadoop, let it be Kafka, let it be Spark, in a very simple language. I can just tell you that these are all distributed computing frameworks at one line, where instead of processing on one machine, you try to process on, let's say, 100 node cluster or 1000 node cluster, so that your hundreds of terabytes of data you can start processing within few hours, which otherwise would have taken probably week of time just to execute and process that data. Do take care of it. I see the data engineering come into picture. Apart from this, as I said that, just go ahead, but where this huge amount of data I want to keep it up, where this will a huge amount of data I want to maintain and manage. I'm very sure to maintain like 100 node cluster, you're not going to purchase 100 machines for that, isn't it? Yes, people are looking for like AWS, correct, cloud, Azure cloud, or let's say Google cloud. They are providing you day by day cloud based services for that. Do understand that. And you must have seen that 90% or like more than 95% your big data solutions, they are running on Linux, guys. So if you're at all planning to work in the big data market, some basic fundamentals you should be knowing is Linux. Some of the basic fundamentals that you should have learned, somewhere you talk about your RDBMS, correct, at least basics. You should be knowing some languages like Python or Java are popular languages nowadays. Think of learning them, where you will be ready. Obviously, if you're working data science kind of stuff, you want to also take a look at maths and stats as well, at least the basic one to get started with. Do understand that. And yes, definitely we have got some of the questions I'm trying to handle. So what kind of job profiles I can getting into this, please note that. So in which domains the big data is available? Now you find that almost every possible domain nowadays, let it be healthcare domain, let it be retail domain, let it be finance domain, let it be security domain, let it be like fraud detection kind of domain. You have got log analysis, or just now I was giving you the example of telecom or IoT and what not. So almost every domain where we have got a huge amount of data, people are talking about big data. So it is, that's why it is it is growing industry day by day. But I said that most important that you should start thinking about the big data. Big data is not only learning Hadoop. Big data is not learning Spark. Big data is not learning only Hive or like learning only machine learning. I personally believe that if you want to learn a big data, please start thinking. Your thinking should be data oriented thinking. So your big data can really begin where you first understand what you should have kind of idea that where I can get a data, correct, what exactly I should do, correct. So you should first think of that. Then you are worrying about how I can collect that huge amount of data. If you are collecting a data in like a GBs or let's say TBs, Now at that time, the question, how do I manage this data? Even though you try to manage that data somehow, how you are going to analyze that particular data, you find that you need to analyze that data. Oh, forget. But then analysis of that huge amount of data is just not possible unless or until you summarize it into some sort of tabular format where you can see some data that you can read it, isn't it? But wait, but this data you can read it, but you cannot really show it to your CEO and he will not be able to understand. Somewhere you want to also visualize that particular data, and not only you want to visualize the data, you want to find out the pattern from that particular data. And once you have got all this summary, you are able to visualize, you understood a pattern. Based on that, yes, you should be good enough in taking up the decisions, guys. Correct? Obviously that is a job at the higher level. But when I say big data, in my opinion, your big data process start from thinking first your project idea, and then end somewhere that utilizing this and coming up with the final decisions. And all these domains where you are dealing with the huge amount of data, I just say that yes, these all data stages in between, these are the big data stages. And this is where we have got options. Hey, what are the options that we have got? Yes, you can try to be a business analyst or business intelligence, where you are trying to analyze the data for that particular business, like sales data and all that, and doing some sort of predictions regarding that. Correct? The second possibility is that you might be right now working at rdbms. Trust me, if you're working at some rdbms which is dealing with the data in terabytes, you are already working in big data. Probably no Oracle enterprise servers that you are dealing with and dealing with the terabytes of data. Yes, you are actually working in big data. You may not be knowing that, but you want to go a step ahead and you want to start using the proper big data tools apart from your rdbms tool. Yes, we have got opportunity as a big data engineers, isn't it? The big data engineers are one who are going to write this kind of jobs, write this kind of scripts, or going to write some sort of code which are going to produce the huge amount of data, and that process that huge amount of data in really shorter time. These are the people who are working on this kind of distributed cluster, and processing that data for you. Apart from this, but that huge infrastructure, 100 node, 1000 node cluster, you need to manage this cluster. If you want to manage, you should be good at cloud, you should be good at linux, you should be knowing how to handle that particular system. I say that these are the IT operations, more of you consider like an admin level job. Yes, people are doing that. It's one of the biggest challenge where you start talking about the security of a data and all that kind of stuff. Yes, people are looking for this. Apart from this, you may not be in a big data side, but you might be worrying about like a AI or ML engineer. Now when I say that AI or ML engineer is a person probably who know machine learning algorithms, who know the APIs for that. And lot of machine learning courses that I have seen around, the most of the courses are trying to teach you the machine learning engineering. So they are telling you whatever the data that you have got, how to extract the features from that data, what are the important columns that you want to process, and then doing a little conversion, making them ready for training the machine learning model, and then actually applying them. Correct? This is mainly the job of machine learning engineer. But trust me, to understand which machine learning model is to be used, or which features are to be extracted, and then probably what sort of processing is to be done, now you need a quite good experience that cannot be really taught in like a typical machine learning course, where yes, definitely you can get an idea what can be done, but you need more or less experience with that. You need to have an understanding of statistics behind the scene, that how the data is there. Correct? The thinking of data is really important. One who can take decision that which features are to be processed, how to be processed, what algorithms are to be used, and etc etc. I say is like a data scientist do this particular job. And this data scientist is one who really understand how you are going to process the data. But apart from this, these data scientists nowadays, they are getting equipped with this kind of big data terminologies as well. So there's like a one position listed as a big data architect. The big data architect is probably the person who understand all this kind of stuff and then able to give the solutions to the customer. And then I'm very sure people are worried about, sir, if so many things that we want to learn. No, not really. Please note that there are quite good chances that you are working in one or two, or let's say, kind of one or two domains out of this. But even though you're working on one or two domains, let me tell you guys, Nowadays it is really important that you are knowing everything. I'll just give you one example. There was an example. Let's say that you may not be a data scientist, I know. You may not be a statistician, I know. But let's say that somewhere you want to process a terabytes of data on yourself. You are not understanding that. Let's say that you can hire some, let's say, data scientist for you. So you can hire him on a contract for XYZ project. So he will definitely try to process some data for you. But don't you think that that data scientist will, after doing some sort of processing, he will try to tell you that you should do these kind of steps. Don't you think whatever steps that he is telling you, even to understand that those steps, you need to have enough of understanding of data science. I'm saying that you may not be a data scientist, but to understand their terminology, you have to have a bit understanding of statistics, you have to have a bit understanding of machine learning. I'm saying that this is something you need. So it is not like so easy that you start saying that I will learn only machine learning, or I will learn only data science, or I will learn only big data. No, this ecosystem, yes, definitely you can try to become master in one. But even though you're trying to become a master in one, you have to have adequate knowledge of many other things. Please do take care of it. Just to tell you that, one great person, like thought leader in like big data world. So like some quote is for you, is saying that the sexiest job in 21st century requires mixture of multidisciplinary abilities, and suitable candidate must be prepared to learn and develop constantly, isn't it? So I'm saying that it is all about keep learning and keep growing, obviously financially as well. I hope I was already telling you that it's a big industry, but definitely you have to take enough of efforts. Probably I just started my career probably 20 years back. At that time, people were talking about specializations. So people were saying that, okay, you should be expert in Java and your career is set. Somehow that is not a trend nowadays. The trend has been changed. Now definitely you have to be expert of one or two things, but at the same time you have to have knowledge of like multidisciplinary abilities. So something I believe you should be aware of. Please do take care of it. Correct? So these are like certain ideas we should be aware of what big data is all about. So where big data is used, so I'll be just talking about another couple of minutes, and then by the time you people have any questions, we will definitely talk about your questions as well. Just to show you where this big data and analytics is used, so you'll find that almost, there's like a landscape. You can definitely find this particular image on a Google, and you will find that the image is so big, I'm not really able to zoom it over here. So like a 4000 by 3000 pixel image is there. You can zoom and you can try to find out, and you'll find that almost every sector, let it be infrastructure, let it be analytics, let it be the applications, let it be your cloud, let it be probably the tools that you are developing, and whatnot. I'm saying that almost everything, there are huge huge amount of requirements are there into the industry. Obviously you cannot directly jump on and start learning something. You need to start making your base. So again, there are like a couple of questions we have, couple of questions that we have. So definitely I'm talking about like certain questions out of that. So people are asking me that how much time it takes, learning, to learn a big data. I would personally say that it will not really take huge amount of time to learn big data. The problem is that it is not what you want to learn or how much time it takes. It is all about from where you are started, what base that you have got. Now someone like fresh engineer, and then he started learning big data, definitely he's going to take probably 1 year or 2 year or even more than that time. But if you're already into this particular area, somewhere into the IT industry, somewhere you are already aware of operating systems, probably the databases, some of the enterprise applications, you are aware of how the things are working behind the scene. Correct? So you can definitely correlate, and you try to learn how these frameworks are built on the top of it. Correct? Things become easy. Again, people start talking about, so how much time it will take to learn data science. Again, you're starting from scratch. You can spend 1 year or 2 years to try to make yourself expert when it comes to data science. But apart from that, you have got like some MSc statistics person who has already spent his 5 years onto the data, so he already has got much better hold on a data. You start teaching him modern data science, he may not take much of time. So what important parameter over here, I would always say that it is not like how much time it will take. It is all about what baseline that you are carrying with you. And as I said that you need to literally start learning almost everything that come along in like IT industry. One more misconception I have seen, like a lot of people, they are keep asking me, so sir, we have heard that big data doesn't have a programming. Oh no, guys, please don't consider like that. It is not like big data doesn't have a programming. Big data also has got a programming. Big data also, you literally to process that huge amount of data as you go into the hive. So we write a queries which literally goes like 40 or 50 or 100 lines long. One query itself goes so big, and probably sometimes the query execution itself takes 6 hours to 8 hours. It is there. So even though you're not writing a traditional program, even writing SQL queries can be challenging at the times. Or you start talking about, you start writing actually machine learning programs. So you want to learn machine learning programs, obviously you should be first good at learning Python. Otherwise you will keep struggling with the Python syntax when some of your faculty is trying to teach you the machine learning algorithm. You should not do that. Something same thing is true for your big data. You want to handle that big data. The languages that nowadays we use are like Java, or let's say Python, or for that sake even Scala. People are using that. Now all these languages, even though you are using, please note that you need to be first good at that languages. So you cannot really say that, sir, I don't know Java, but I want to write a Hadoop MapReduce job in Java. Now it will really face challenge. So please, if you want to make your career into the big data, whatever, basically traditional IT is something I believe you should definitely learn. You should not skip that and directly jump on learning big data. There is no alternative. The tools get changed. So probably even the data visualization tools are there, like Tableau. I know that many of my friends, they are working on a Tableau, but at a certain level, you get something ready-made, drag and drop kind of options. Apart from that, you need to customize your Tableau plugins at the time. And to customize Tableau plugins at times, you need to write the code into the Python. I'm saying that everything is important. If you really want to attain a good level, I said that don't put anything into the option, keep learning. And over the period you'll find that you may not need to use Java a lot. Over the period you may not need to use programming languages a lot. But while entering in this particular big data spectrum and big data companies, the opportunity that you are trying to get it will always happen that at the entry level you will be screened for everything. At that time you cannot really keep on saying that, sir, I'm not good at programming, or I'm not good at, let's say, mathematics, or I'm not good at this, I'm not good at that. No excuses are allowed. Please do take care of it. There are few more questions. Like one of the question is talking about what is Apache Spark. What is Apache Spark? I said that let it be Hadoop or let it be Spark. These are the distributed computing frameworks. Instead of doing everything on like a single machine, you have got the set of machines, and whatever your data that you are trying to process, that particular data, you say that some partial data processing over here, partial data processing over here, partial data processing over here, partial data processing over here. I say that this is your distributed computing framework. What I say that it's a distributed computing framework. But sir, from where data comes with? Please note that your data may come from a HDFS, we say Hadoop cluster. Your data may come through that Amazon S3. Your data may come through that Azure file system or whatever. So you are getting a huge amount of data from any of the sources, but you are trying to process that data onto this. I said that it is there. So like one of the question that was there, what is Apache Spark? I just say that it's like a quick introduction that you can say that it is one distributed computing framework. It allows you programming, into the Scala language in which Spark is written, or probably into the Java language. But I was just checking that you find that the latest, if you see that the majority of programming nowadays is done into the Python. Please take a look at that. You might be interested in doing PySpark is something that is getting popular day by day. Correct? There's another question that we have. is that when and how to decide to move to big data than traditional RDBMS. I guess I already answered on this. So moving from traditional RDBMS to big data, please note that you need to work on these V's. You talk about the volume, you talk about velocity, you talk about variety. Please do take care of it. If you know about these V's, if your problem statement is fitting into these V's, I'm very sure you want to take a look at and you want to think of like going from RDBMS to big data. I'll just give you like one of the quick example. Probably you talk about like kind of movie recommendation system. So movie recommendation system is one, even though you have got hardly 1 MB of data, you might find that you got data coming from the different users and ratings. Example is like pretty simple, but wait, when you start applying algorithm on that, you need to literally compare that your 1 lakh records with all 1 lakh other records. So 1 lakh records can be a really small amount of data, but when you say that you are trying to make a kind of a cross join over there, 1 lakh into 1 lakh becomes a huge amount of data. And you'll find that you start doing it in a typical RDBMS on your regular machine, there are likely chances that it will crash your system. Correct? It will happen like that. Please do take care of it. Correct? Yes, people are also talking about this. One more question I have got, that people are saying that what is cloud computing? Cloud computing with respect to big data. That's why I say that nowadays you go for AWS or you go for Azure, all these people have realized the potential of big data, and that's why they started providing you the services for that. You find that AWS MapReduce is kind of a service. So that is one of the EMR service, Elastic MapReduce service is there. Something similar, your Azure has got a service for the Spark and kind of Hadoop as well. There are even companies, let's say you talk about Databricks is a company, leading company into the Spark. So they have got their own cloud services. Or for that sake, you talk about Cloudera and Hottenwork, which are merged like last year. You found that even they are providing you kind of a online cloud-based services available. Please note that there are so many facilities are available. Obviously, for that, what should you be knowing first? You should be first knowing basically what AWS is or what Azure is. But only that much knowledge is not sufficient. At the same time, you have to be aware what Hadoop is, what Spark is. Even though you are not really doing a programming of it, it is worth, as I said, that you must be having enough of knowledge. I know some of my students, they are right now they are into the this kind of administration job, so they are like AWS certified or like Azure certified, and they are probably working into the companies right now. Correct? Even the companies like Cloudera and all that, so they are working over there. They are working as a like administrator, senior administrator. But even you ask them, please note that they are well aware how Hadoop program works. They know it very well how Spark program runs. Even though they are not writing program every day, they are aware, because unless until they know, they cannot manage the system. Please do take care of it. So yes, definitely, if you are going for a cloud services, answer is very simple. You choose, AWS is one of the prominent, Databricks is prominent, even Cloudera is prominent, or let's say for that say Mapr is prominent. So these are very good as far as big data services are there. Correct? You should be knowing them. At the same time, you should be knowing the big data concepts as well. Do take care of it. There is one more question that on the way. Sachin is having a question. Please suggest a good path of learning in this field. Basically, I'm confused where to start from. See, again, as I said, that it is always very important from where you came from. As I told you, first and foremost, I would say that whatever your basic programming skills or basic IT knowledge that you have, you must be good at that. Please don't skip that ever. I'm saying that IT knowledge means what I'm saying, that you should be aware of understanding the basic of operating system or basics of your networking. You need to know. Correct? You always think of your basic programming skills should be ready. Correct? As I said that these are like basic, your IT foundations should be there. Then you take a decision where really you want to make a career into the more of data science kind of line. I suggest, my personal recommendation, I suggest, why not you go ahead, spend a little time, and learn your statistics or mathematics back. It is worth, guys, spending 6 months of time going back and learning the maths and kind of stats related concepts, because they will give you enough of understanding of a data than the actual algorithms. algorithms can be, definitely you can learn it over the period, correct? And after that, you move further, you start learning your machine learning, or let's say deep learning, or for that sake, you have got interest more into like a mathematics and something like that. I'm very sure you must be also interested into the AI kind of field. So I'm saying that the steps that you want to follow, correct? But if you're having interest more of like a big data kind of stuff, please note that yes, you want to go ahead apart from your traditional database. Don't skip learning basic rdbms and jump to the big data. You have to have understanding how to write a sql queries and kind of stuff. But then later on, you have to find out how you can manage a huge amount of data into the cluster. This is where you can start thinking of working into the Hadoop. Nowadays people keep saying me that so Hadoop is not that used. Please note, Hadoop day by day is becoming part of your system. Yes, definitely over the period, Hadoop MapReduce is like people are deprecating it, but your HDFS is kind of a de facto standard and people are using it at many different places. So, understanding of Hadoop will build some basic foundation. And then over the period, even though you don't want to continue with Java programming, yes, nowadays you want to talk about Spark, you talk about Presto, you talk about Apache Drill, you want to talk about like many different frameworks are there. Yes, definitely you can start with some foundation ready, and then you can start exploring what all specialization that you want to get into the, correct? So that is where it will take you a discuss like a lot of questions, how you can really deploy your machine learning services. Definitely you need to be first in a position to start deploying your machine learning services into the big data world, correct? So that is where it will take you discuss like you have got like a lot of big data problems and you're handling. There's another question, how you can really deploy the big data solution. I believe that this is like a too advanced question to start with at this moment. But definitely you need to be first in a position, you develop the big data solution. First you develop your machine learning services, then you can start exploring what all specialization that you want to get into. So once you have got like a lot of big data problems and you're handling, there's one other question, how you can really deploy your machine learning modules. So once your machine learning modules are like Azure or something like that, and people are using them heavily into the market, correct? So please think of that, using this kind of cloud services where you can start deploying your machine learning services. These are most common. Instead of people doing it by hand, I have seen that most of the project they are using either AWS services or let's say Azure services, or even for that say Databricks or Cloudera services are available ready for your deployment. Only thing, this for machine learning, same thing is true for your data engineering or your big data solutions. Definitely your most common scenario I have seen that people are going on a cloud based services only. So as the question is that big data solutions you want to deploy, you need to have to learn about these cloud services which are available, and you need to examine and to evaluate which one is best suitable for you. I hope we try to get like a lot of questions and try to give you the idea what all you can learn into the big data world. I'm very sure this particular session would be very much helpful for you. Apart from this, definitely at Sunbeam we keep conducting trainings in machine learning. Right now the batch is going on, so we are even probably conducting trainings onto the big data, like working on Hadoop, on Spark, on Hive and all that. Nowadays, with the pandemic time, we have started all these sessions onto the online, correct? So we have got like couple of sessions are available on our website for like upcoming weeks. If you're interested in, feel free to go ahead, check our website, and you can try to register over there, right? I'm very sure you have enjoyed this particular session. So thank you very much.